and today we're doing a video about the ecliptic. One of the things I often hear in response to why we can't see Nibiru or Planet X clearly is because it's below the ecliptic. This is often given as a reason in response to some of my videos when I challenge people and say, well, you know, if Nibiru and Planet X is really there next to the Sun or in the sky somewhere, why can't astronomers from all around the world see it? And the response often comes back, well, it's below the ecliptic. It's as if it's out of sight. It's a bit like saying it's below the horizon, so you can't see it. But it doesn't work that way, and in this video we're going to take a look and see exactly what this ecliptic is and what it means and how it works. So first of all, what I'm going to do, we're looking at the view from New York. This is looking around. We've got Central Park there, and we're looking towards New York. And as you can see, we've got the Sun in the middle of the sky. And here's the Sun. I'll just select that. Okay. Now the ecliptic. The ecliptic is the path that the Sun apparently takes through the sky. Now, of course, the Sun does not orbit the Earth. The Earth orbits the Sun. But because of the Earth's rotation, the Sun takes an apparent path across the sky as the Earth turns. I'm going to turn on the ecliptic, and we're going to see this green line arcing across the sky. And if I move time back, you can see the Sun is moving towards the east where it rises, and if I move it forward, we can see the Sun going across the sky. And you can see this green line, this arc, is sort of following the Sun as we go. Now, the planets as well also approximately follow the ecliptic as well. They're not right on the ecliptic. Sometimes certain planets will be right on the ecliptic depending on where they are in their orbit. So what I'm going to do is I'm going to turn on these markers for the planets so you can see them clearly as well. And Saturn and Uranus and Neptune. Okay, so as you can see, we've got a bunch of planets which are pretty close to the ecliptic there. Now, as I said before, a lot of people are saying we can't see Nibiru or Planet X because it's below the ecliptic, as if it's below the horizon. Well, you can see here that, and this is a northern hemisphere view. I mean, I'm in New Zealand, which is southern hemisphere, which means everything's upside down. But you can see that we can see the ecliptic line here, and we can see above the ecliptic, and we can see below the ecliptic, right? In fact, we can see a long way below the ecliptic. Now I'm going to do something else here. I'm going to view the ecliptic poles as well. Alright, now if I move this round, we can see the north ecliptic pole. Now what I've actually done there is I've actually had to turn around and basically look towards the north, because we're looking towards the south here. Okay, now in the northern hemisphere the Sun crosses the sky in the southern half of the sky. In the southern hemisphere it's the opposite. The Sun crosses the sky in the northern half of the sky. So what I have to do is rotate round so that we are looking north. This is north. You can see the marker there if you've got your high definition viewing on. And this is the north ecliptic pole, so we can see all the way up to the northern ecliptic pole. Now the other thing I'm going to do is I'm going to turn on the celestial poles as well. So that's the north ecliptic pole, and this is the north celestial pole, so that's the northernmost point in the sky. Now I'm going to turn the daylight off so we can see the stars clearly, and we can more clearly see the ecliptic and the planets in the sky as well. You can see Jupiter, Venus, Mars, the Sun is here, Uranus, Mercury, Neptune, all approximately following the ecliptic. And again, this is the north ecliptic pole, so this here is above the ecliptic, and this is below the ecliptic. So even from New York or anywhere in the northern hemisphere, we can see well below the ecliptic. That's not a problem. But what if we change our location? What I'm going to do is change our location to Auckland, New Zealand in the southern hemisphere. So here we are now in Auckland, New Zealand in the southern hemisphere, and as you can see we're looking straight at the south celestial pole, and below that we've got the south ecliptic pole, and we can see the ecliptic is arcing across the sky. Here again we can see the Milky Way, And for anyone familiar with the southern hemisphere sky, You can see the 2 pointers and the Southern Cross here. Now we don't have a pole star in the southern hemisphere, such as Polaris in the northern hemisphere, so we don't have a central star that we can watch the stars rotating around. But doesn't change the fact that the stars still do rotate through the sky. If I speed up time, we're going to see this happening. In fact, I'm going to have to go the other way because it's nearly sunrise. So as I speed up time, we're going backwards in time here. You can see the stars are rotating around the central point. And here's the south ecliptic pole. Here is our ecliptic. So to say that Nibiru or Planet X or anything can't be seen because it's below the ecliptic is nonsense, because we can see well below the ecliptic from the northern hemisphere, and we can see all of below the ecliptic from the southern hemisphere. In fact, we can see to the south ecliptic pole. So next time somebody says, well, Nibiru or Planet X can't be seen because it's below the ecliptic, as if to say it's below the horizon or some magical thing like that, it's nonsense. Okay, anyone in the southern hemisphere can see below the ecliptic, and in fact they can see all the way to the south ecliptic pole. So I hope that's cleared that up. Any questions, just send me a message or leave a comment under the video. And as always, do check out my Facebook discussion page, Voices of Reason to Explain X or VORTEX. I'll put a link for you in the description area. Thank you for watching. Hello YouTube, this is Dazza the cameraman, and today we're doing a video about the ecliptic. One of the things I often hear in response to why we can't see Nibiru or Planet X clearly is because it's below the ecliptic. This is often given as a reason in response to some of my videos when I challenge people and say, well, you know, if Nibiru and Planet X is really there next to the sun or in the sky somewhere, why can't astronomers from all around the world see it? And the response often comes back, well, it's below the ecliptic. It's as if it's out of sight. It's a bit like saying it's below the horizon, so you can't see it. But it doesn't work that way, and in this video we're going to take a look and see exactly what this ecliptic is and what it means and how it works. So first of all, what I'm going to do, we're looking at the view from New York. This is looking